Hi, I see that you're doing indefinite integrals, and that's a pretty hard topic, but I'll see if I can help. So I thought I'd help, and maybe it would help if I made you a video. Maybe it won't. So your first problem was x squared times the square root of 1 minus x dx, and they wanted you to find the integral. They called this an indefinite integral, and it's indefinite because it doesn't have limits of integration. Those are the numbers that are at the top and bottom of the bar there. So since there aren't any, it's called an indefinite integral. So they want you to use the other name for what they called that was substitution. So maybe you can look up and find some things on substitution. But you use this when you're trying to undo the chain rule. If you look here, this looks like these two things could possibly be some form of the application of a chain rule when someone was taking an antiderivative, or since you're going backwards. And you do that so that you can simplify this enough to take the antiderivative. So there's a lot of trial and error with this, but I'm going to let u equal 1 minus x. And if you pick the wrong thing, you're going to hit a dead end. Sometimes you can do this multiple ways. You don't always have to pick the same thing I do, but that's what I think will be the easiest. So I'm doing this because I want to get rid of all these x's. Anything with an x in, I'm going to get rid of, and I'm going to turn it into a u. And you'll see why, hopefully, in a minute. So I'm going to let u equal 1 minus x. If I let u equal 1 minus x, if I take the derivative of that, and I don't know how they wrote derivatives, but you can do dy dx, you can do dt dx, or you can call this f prime. There's a whole bunch of different notations, and unfortunately that's because a bunch of people came up with calculus at the same time, or a few people did, and there's not one standard way to do this. So if I take the derivative of my expression u here, the derivative of u with respect to x is just -1. Okay, that's pretty easy. But you'll notice here that one of the things I'm going to have to get rid of is that dx. So I want to isolate dx here, and I can treat this here like an equation, and I'm going to multiply both sides by dx, and I get du equals negative dx. So I am going to be able to replace this dx if I divide both sides by -1. Okay. So that gets rid of that. And I'm going to go ahead and do that now. Negative du is going to replace this dx. Okay. And then u is 1 minus x, so I can replace this here with u to the 1/2, or the square root of u, whatever floats your boat. And then I have x squared that I need to get rid of. And it's not immediately obvious to me how to replace that x squared, but if you look back up here at u equals 1 minus x, I can rearrange that so that u minus 1 is equal to negative x. And if I divide everything by -1, I get x equals 1 minus u. Okay. Then x squared is 1 minus u squared. And I'm going to go ahead and replace this here with 1 minus u squared. So I have 1 minus u squared times u to the 1/2 minus du, or times negative du, sorry, not minus, times negative du. Oops, that was an accident. Let me erase that. Find my little eraser here. Okay. Now, an important thing you should do anytime you're taking an integral is you should simplify things if you can. So I'm going to go ahead and expand this so that I can simplify it. At the same time, I'm going to get rid of that negative. The derivative or the integral, since I'm multiplying by -1, I'm going to take that outside the integral. I'm going to multiply the integral by -1 too. But 1 minus u squared is 1 minus 2u plus u squared. And that gets multiplied by u to the 1/2. And then we're taking the derivative with respect, or the antiderivative with respect to u. So then I can simplify this even more. I can FOIL all of this out. And I'm going to write it in descending order because I'm kind of anal like that. U squared times u to the 1/2. I keep the base and I add the exponents. So that would be u to the 5/2. 2 plus 1/2 is 2.5. All right, and then minus 2u to the first. So 2u, and then 1 plus 1/2 is 1.5, which is 3/2. And then 1 times u to the 1/2 is u to the 1/2. Okay. Now I can go ahead and take the antiderivative. So I still have this -1 out front that I have to deal with later, but I add 1 to the exponent and divide by the reciprocal. So 2.5 plus 1 is 3.5, which happens to be 7/2. So that's my exponent. And then I divide by the reciprocal, or multiply by the reciprocal, or divide by the same number, same thing. And then minus 2 times 3/2 plus 1, it's going to be 5/2. So I'm going to multiply by the reciprocal, 2/5 u to the 5/2, plus, and then add 1 to 1/2, and I get 1.5, which is 3/2, which the reciprocal of that is 2/3. And now that I have the antiderivative, I can drop the du. Now I just need to simplify this a little bit. And I also need to distribute this negative sign everywhere. Can't forget that. So I end up with the antiderivative of this being -2/7 u to the 7/2 plus 2 times 2 is 4. So 4/5 u to the 5/2 plus, minus 2/3 u to the 3/2. Okay, let's do one more. I'm sorry if I'm boring you. This probably is really boring. Let's do the next one. So I have x squared minus 1 over the square root of 2x minus 1 dx. That's dx squared. Okay. I'm going to let you, again, I wouldn't have any idea where to start that integration process here. And if it makes you feel any better, not everything can be integrated. It's kind of like, I guess, guessing game. But I'm going to let u equal 2x minus 1 because I think I can get the bottom and the top pretty easily from that. Then du dx, the derivative of that, is just 2. And then that means that du is 2 dx. If if I multiply both sides by dx. And then I want dx by itself because I don't have 2 dx over here, I just have dx. So if I divide both sides by 2, I get 1/2 du is equal to dx. So over here, I am going to I'm going to bring that 1/2 out. I don't need it over there. It's just going to annoy me and get in my way. I could leave it. That's fine too. But it just makes things more complicated. And since everything gets multiplied by 1/2 inside the integral, then I can go ahead and take it out. All right, so I have that, and then I have the square root of u in the bottom here. And now I just need to figure out how to get x squared minus 1. Well, if I go back up here, u equals 2x minus 1. If I want to get x by itself, so that I can replace that x squared up here, I'm going to do u plus 1 equals 2x, and then u plus 1 over 2 equals x. So that would mean that if I squared x, then u plus 1 over 2 squared, I could replace this here, this top. So I get u plus 1 over 2 squared. And that doesn't look very much better that way, but let's go ahead and try to simplify it. So 1/2 u plus 1 squared is going to be u squared plus 2u plus 1. Oh, I forgot the minus 1. Can't leave that out. Over 4 minus 1 over u to the 1/2. The next thing I'm going to do is I'm going to separate this top here. So this would be 1/4 u squared, because it's u squared divided by 4, plus 2/4 u plus 1/4 minus 1. All of that's over u to the 1/2. All right, so then from here, I can combine these two terms because they're both constants. They're ugly, but they're constants. So 1/4 u squared plus 2/4 u minus 3/4. All of that over u to the 1/2. Oh, I keep dropping the du, sorry. You can't drop that till you take the antiderivative. Now, if you look here, everything has a 1/4 on the bottom. I'm going to take that 1/4 out. So I have 1/2 times 1/4, just because it's annoying. And then I have u squared plus 2u minus 3, all in the top, divided by u to the 1/2. Or I could times that by u to the negative 1/2. Same thing. And I can go ahead and simplify this. U squared times u to the negative 1/2. I go ahead and add the exponents, and I get, I'm going to rewrite this. I get u to the 3/2. And then u to the first minus, or times u to the negative 1/2 is going to be 2u to the 1/2. And then minus 3u to the negative 1/2. All of that. Okay, now I can go ahead and take the antiderivative. So I still have that 1/8 on the outside I have to deal with later, but 3/2 plus 1 is 5/2, so that's going to be 2/5 u to the 5/2. And then plus 2 times 1/2 and 1 is going to be 3/2, so 2/3 u to the 3/2, and then minus 3 times negative 1/2 plus 1 is going to be positive 1/2. The reciprocal of that is 2 u to the 1/2. And I can go ahead and drop that integral. Now I got to multiply everything by 1/8 as well, and I get, shoot, I forgot to tell you on the last one to do this, but you have to add the constant c at the end since it's an indefinite integral. All right, so 1/8 times 2/5 is going to be 2 over 40, which is 1 over 20, u to the 5/2, plus 2 times 2 is 4 on the top, and 24 on the bottom. I'm going to make that 1 over 6 then. Get my eraser out. U to the 3/2, and then that's going to be negative 6, so minus 6 u to the 1, forgot, 3/2, so 2/3. So I have to multiply this by 2/3. 6 times 2/3 is going to give me 12 over 3, so 12 over 3 is 4. So that's actually minus 4 u to the positive 1/2. And then add the constant and you're done. Okay, I'll let you try the other one that's like that on your own, just because I don't want to bore the heck out of you. So let's see. Another problem you had was, to find the extrema and the points of inflection and sketch a graph of this function here. So we have 2x minus the natural log of 2x. All right, so that, I don't know if you know this, and pardon me if you already do, I don't want to bore you to death, but a derivative is a slope, right? Whatever, when you find a derivative at a point, it's the slope of the function at that point. That's what a derivative finds. So if you want to find a minimum or a maximum and you think about it, if I have a maximum here, the slope at this point is 0, because if I draw a tangent line to my curve, it's flat, so the slope is 0. Otherwise, it's not a min or a max. So in order to, and if you want to do a sketch of a curve, usually you're looking for a rough drawing with key points, and minimums and maximums and points of inflection are key points, and you don't want to have to plot a bunch of points. So some things to think about. First, we want to find first derivative. First derivative is going to give me mins and maxes. So, oh boy, so 2x, the derivative of 2x is 2 minus, and then the derivative of the natural log of x is 1 over x. So this is a composite function, and I need to use the chain rule, but so it's the derivative of the outside function, 1 over 2x, you leave the inside function alone. This is anything in parentheses is an inside function, times the derivative of your inside function. And the inside function again is 2x, so I'm going to take the derivative of 2x, which is 2, and I can simplify that down to 2 minus 2 over x, 2x, sorry, which is the same as 2 minus 1 over x. Okay, so that's the derivative. If I set that equal to 0, because that's where I'm going to have a min or a max. Oops. Getting sloppy here. All right, so 2 minus 1 over x equals 0. I can subtract 2 from both sides, and I get negative 1 over x equals negative 2. Negative 1 equals negative 2x. So x equals 1/2. So at 1/2, I have a minimum or a maximum. And it doesn't appear that there's anywhere else that I would have one, because there are no other values that are equal to 0 on this function. Another thing to consider is the domain and range of this function. And if you remember anything about logs, I can't take the log of a negative number. Why is that? Because I can't. Too long to go into. So whatever's here has to be a positive. It has to be greater than 0, because I can't take the log of 0 either. So x has to be greater than 0, or there's not a function. So I got to keep that in mind. And at 1/2, so here's 1, 2, 3. At 1/2, I have a minimum or a maximum. Okay. I don't know which. That's my issue. And if I wanted to find points of inflection, that's where the second derivative equals 0. So if I take the second derivative here, f double prime is 0, that's not going to work. There's not going to be a point of inflection because it doesn't, that would be invalid for my function. So I either have a minimum or a maximum and nothing else. Okay, so if I go ahead and plug in 1/2 into my original function, I get 2 times 1/2 minus the natural log of 2 times 1/2. So this is going to be 1 minus, and then the natural log of 1. If you remember anything, if you remember, the natural log of 1 is 0. So I have a point at 1/2, comma 1. That's one point I have. So at 1/2, I have a point at 1. That's either my minimum or my maximum. Now, the way that I'm going to be able to tell a little bit about this graph without doing too much. So I have, this is my 0 of my derivative. I want to see what happens on either side of this minimum or maximum. So I need to plug in a value to the left and to the right to figure out, because it's a slope, if my slope is negative, so if my value is negative, that means, since it's a slope, that the function is, if the slope's negative, the function's going this way, it's decreasing. If the value is positive, that means my slope is positive, and that means that the graph has to be increasing. So if I go from negative to positive, so decreasing to increasing, then I have to have a minimum. If it's the other way around and I go from positive to negative, so increasing to decreasing, well, then I have a max. So what I need to do is figure out whether the values of x in the derivative are going to be positive or negative around this minimum or maximum. So a good point here would be maybe to plug in 1. So if I go ahead and plug 1 into my original equation, I get 2 times 1 is 2 minus the natural log of 2 times 1. So 2 minus the natural log of 2. So I have a point at 1 comma 2 minus the natural log of 2. That's a positive number. How do I know that? Well, the natural log of 2 is a positive number, but it's not a very big positive number. It's a decimal, but it's not very big. I'm not going to go ahead. I could calculate it, but I don't really feel like it. This is good enough. So if I can't plug in 0 on the other side, because remember, x has to be greater than 0. So 1/4 would be a nice number, probably. So at 1/4, if I plug in my value 1/4 here, I get 2 times 1/4 into my original function. Where'd it go? Up here. So I get 2 times 1/4 minus the natural log of 2 times 1/4. That gives me 1/2 minus the natural log of 1/2. Okay, so natural log of 1/2 is actually a negative number, because if you remember the graphs of log functions, if they don't have any transformations, they start, they have a point at 1 comma 0, and then they look like this. So everything to the left of 1, between 0 and 1 is negative. So I have 1/2 minus a negative number. This is a negative number. So I go from a negative slope to no slope to a positive slope. Negative slope, no slope, positive slope. That's going to be a minimum. So this function has a minimum, and it probably looks something like this, or something. That'd be a good rough sketch. Okay, another problem you had was they wanted you to find the natural log of x times the square root of x squared minus 1. Sorry, that does blow. It's not going to be easy. It's kind of complicated. But I have, again, if we think about it this way, I have f of g of x here. Because f of x would be the natural log of x, and g of x, God help us, is x times the square root of x squared minus 1. Okay. In here, I have other issues I'm going to have to deal with, but I'm going to go ahead and use the chain rule, and it's f prime g of x, leave the inside function alone, and then times the derivative of the inside function. So the derivative of the natural log of x is 1 over x. So 1 over, I'm going to leave this inside function alone here, x times square root of x squared minus 1. Now the tricky part is I'm going to need the derivative of this. And unfortunately, that is a lot, because I have the product rule, because I have two functions multiplied together. I have x times square root of x squared minus 1. And I also have in that the quotient rule. Not quotient, sorry, chain rule. Again. Because I have my outside function is the square root of x, and the inside function is x squared minus 1. So I have to do the chain rule again. I have to do that again once I get to that derivative. And the product rule, if I have two functions, f times g, then it's f prime g plus f g prime. All right, so the derivative of x is 1 times g, which is square root of x squared minus 1, plus f, and then g prime is where I have to do the chain rule. Don't have to do it till you need it, but the derivative of the square root of x squared minus 1, the derivative of the square root of x is 1/2 x squared minus 1 to the negative 1/2. And then I need the derivative of the inside here, x squared minus 1, and that'll be 2x. Gross. Okay, let's clean that up. So I have 1 over, I hope I don't make any mistakes for you, 1 over x squared minus 1. So since I'm multiplying it, actually I'm multiplying by this whole thing, times x squared minus 1 plus x over, let's do, x times 1/2 times x squared minus, oh, I'm going to get rid of that. This is going to be, since this is to the negative 1/2, it's 1 over 2 square roots of x squared minus 1. And then I still have 2x at the top, so times 2x. Okay. This is just gross. All right, so on the top, I have 1 times this whole thing. So in the top I have x squared minus 1 plus x. Oh, x times 2x is going to be 2x squared. And then in the bottom here, I'm going to go ahead and throw that down in the bottom because that's where it belongs. X times 2 times x squared minus 1. I have 2 of those, so I'm going to square them. And actually that helps me out a little bit because I get 2x squared plus square root of x squared minus 1 over 2x times x squared minus 1, because I can drop the radical because I can. And I'm left with 2x squared plus the square root of x squared minus 1 over 2x cubed minus 2x. Okay, I don't know if you can simplify that more. You probably can, but hopefully you get the idea. All right, let's do one more example of integration. I have, derivatives. G of t equals the natural log of t over t. I can use the quotient rule for that because I have a function divided by a function, f divided by g, f of x divided by g of x. And the derivative for that is f prime g, just like the product rule, minus f g prime. And so the only difference is that I have a subtraction sign in the middle, not addition, over g squared, over the bottom function squared. So the top is f prime. The derivative of the natural log of t is 1 over t. And then g is the bottom, times t, minus f, the natural log of t, times the derivative of t, which would be 1, over t squared. So t times 1 over t is just 1 minus the natural log of t over t squared. And that one I know is simplified correctly. Okay, sorry I don't have time to do more. I hope this helps some. Please feel free to email me if you want. And you could, when you're on spring break, come by and bring a lot of questions, because I could actually sit down with you for a while, for a few hours if you wanted. Hopefully this helps though. Bye.